the agenda is quite packed, but we'll spend some time to explaining why from visualization team I ended up inventing a new language in JavaScript, which sounds crazy to me at the beginning, but well, I did it twice since I've been working in this team. And after a brief introduction into grammar, we'll walk through the abstract syntax tree and learn how to build a basic validation engine and an autocomplete engine for this new language. And then how to integrate a very brief intro to how to integrate everything into Monaco editor. So let's start on the why. So I joined this team working on this beautiful editor, and we were asked to add these new features incrementally. So can you add these new way to analyze my data? And well, of course, then function B, function C, and then because we had this nice click experience, drag and drop and buttons, everything was nice until we reached a point where UI was really constrained. We had very small space to offer all the features to the customer, and we had to make trade-offs. Of course, we demanded everything to the UX experts, right? They know how to solve this. And then customer asked to add even more things, how to combine existing things. And that was the complex part, because UX just gave up at one point. That would be too complex. So we were aiming for this kind of UI at the end. So, you add all the new cool buttons and then all the options underneath, and you use accordions and all these kind of patterns to hide most of the complexity here. But it didn't work. I mean, it works for the basics, but we want to add even more, and we don't want to constrain too much the user on what it can do. So we decided to analyze our audience. We have an audience of customers who actually like to write. So we took a step back and thought, what if we offer a very simple text-based interface? So isn't this much better than what we had before? I mean, everybody is used to that, right? In this room, I hope. But, well, let's be honest. It's as nice as the power of the language you use. So the user experience of the language and of the editor must be great. Otherwise, this is terrible. So let's start from the beginning, from zero. Has anybody ever written a grammar, a DSL? Okay, 1, 2, 3 in the room. So, okay, you may already know these things, but I'll go with a very basic intro to grammars. I'm not a professor. I don't know much of the theory. So let's start with something very basics. A grammar is a set of tokens, very basic building blocks, and a set of rules that says to a program how to combine these tokens together. There are many types of grammar. I mean, people spend a lot of time writing papers on this grammar. We're going to use a very simple one for the talk today, which is the PEG. It's a simple grammar, yet it's possible to write JavaScript in PEG. I know there is a talk about that. I'm not covering that. So let's focus on a much smaller scope for this talk. And we decided to write I decided to write a grammar in PEG, and I'm going to use a library that will generate a parser. So a parser is something that takes a string as an input and will output an abstract syntax tree we can then use for more high-level services. Everything starts with an expression in a grammar. So this is an opinionated quote, because I'm using a library called Peggy.js, but there are other libraries out there like OM.js, which use program as an entry point. But the baseline is you need an entry point, and I call this expression. And an expression is made of two parts, a head made of a term type and a tail made of something else. You can see there is some sort of order in the way the grammar is defined. So plus and minus has a precedence over multiply and divide. And then there are other subtypes can be defined. So factor is recursive. So you can call expression from the top. It's just a way to say you can write a statement within round quotes. or can be expressed with a slash. So a factor is either an expression wrapped in quotes or round brackets, or an integer. So if you're thinking, well, I can do better than that, I can just write regular expression to write my own language, right? And I mean, it's true. If you actually open a parser generated by any of these libraries, there are regular expression, but then you have to maintain it. And the author of these libraries, any library that can handle grammar, wrote few papers out of that, and they know how to write safe regular expression, and they take the burden to actually maintain them. So it means you don't have to maintain a regular expression, and they know how to escape and all the hard stuff about regular expression and where to use them and where not. So this is a very basic grammar. So what it does, it takes an arithmetic expression like that and just outputs the number in it. It strips out everything. But I had to fit something in a slide, so I went for a very basic. The nice thing about this PEGI grammar is that you can inject JavaScript within the grammar. So take this function that actually takes the building blocks of the grammar and just perform the sum, the difference, and everything, and put inside the grammar I've shown you before. So next to all the grammar specific language, you can put in curly braces JavaScript code, and you can write something like this. So for expression and term, we are calling the doMath function I've shown you before, while for the factor, we're just extracting the content from the brackets. And for integer, it's not just about regular expression, we're making it an actual JavaScript number. So given the same expression there, we can get out the actual result. We evaluate within the parser itself. Okay, this is a little extreme to do within a grammar. So the idea is to build a language to do data analysis like this. And we're gonna start with a grammar like the one I've shown you before, just using different JavaScript function. The function we're gonna use will be leveraged to create a custom AST. So an abstract syntax tree which respects some specific TypeScript interfaces. So it's easier to work with that. And we're not going to do evaluation directly in the grammar. So from this, few tips and tricks I learned while doing this twice. So I made the error at least once. Balance the grammar when you define it, which means don't try to be too strict. When you define a grammar, you define actually a library, and you can have higher level services for that. So take functions. If you want to define functions, command, whatever in your new language, don't try to list them all within the grammar. Try to write something like there is a piece of text with, I don't know, open brackets. That's a function. Doesn't matter the actual content of the text. Validate that later. And that's because every time you change something, update the grammar, you have to compile it and then ship it. And in general, it may introduce some breaking changes. So don't try to bake all the functions within the grammar itself. Try to be relaxed on that side and delegate to some other service for these kind of things. You can bake, for example, symbols within the grammar. If you think about a math-based language, you probably need 6, 7 symbols, plus, minus, multiply, divide, probably power, modulo, and a couple more. You won't add symbols every single month to your language, while functions, you may have somebody asking you, can you add this, can you add that, like at the day level. So try to think about that. Also, when you design, try to combine top-down thinking with both bottom-up. So having a playground where you can prototype with your new grammar, it's quite easy to get lost into the top-down thinking about languages because they can get very complex. It's true that they have a structure, so they have a hierarchy, but it's easy to get lost into recursion. So having a playground is pretty nice as approach, and it will speed things up a lot. Okay, so imagine in your grammar, you write few functions to make it comply with this AST type. We have fundamentally three types: literal, column, and function. When I say column, I imagine a language where you pass a CSV and takes the column of the CSV as an argument. So you can do math like average of this entire column. A literal is just a number 2, 3, 5, something like that. You can see in the type of the function, it accepts a set of arguments. So this is one thing about being relaxed. So argument can be anything, a function, a column, a literal. We delegate the actual validation to the validation engine later. With this AST, we're going to define 4 APIs. So the parser one is the one provided by the library. On top of that, we're going to build something like evaluate. So you accept an expression with some metadata and will output the final number. And then there is a validate and autocomplete API. Now, you can see there is a second argument called data, sometimes metadata in these things. And that's about the metadata, which is a set of features that include both, if you're talking about data analysis, a CSV, for example, but also things like which functions do we want to support? What are the types associated with the function? So building a validation engine is the first step. And that will help you to understand the power of the language. Validation is a wide term, which means that it's not just about syntax validation. It can mean many more things. The first thing I was asked while designing a language was, we just want basic validation. So what does exactly mean? Because if you mean syntax validation, that's provided by the grammar library. And to be honest, it's almost useless. The error messages are completely useless. A final user cannot read it and understand it. I mean, I struggle to understand it. So I can imagine somebody else who didn't write the grammar itself. So you have to handle those, and you have also to enrich that kind of information with some type checking as well, because it's useful to know that you cannot run an average of a text column. I know it doesn't sound like a complex thing, but it's quite easy to get lost if you have a CSV with 100 columns to like mistype something. Also for functions, it's easy to get lost with arguments if you have complex functions. For example, the order of arguments or the type of the arguments, the options to provide to the functions. So validation will do all these things. It might sound a little bit too complex, but at the end, it's just a function that accepts an AST and a bunch of metadata informations and outputs a set of errors and warnings. The skeleton of a validation is something like this. So, I forgot the error line first, the first line, sorry. But the idea is you parse the expression, you get the AST, and then you just go through a queue that accumulates all the arguments of various functions. And you can use the metadata to get the function definition and run through that. So one little thing here is I try to condense everything into a slide, but it's much better to split especially the function logic into somewhere else and have it test properly, because it's quite easy to get lost, especially if you allow nesting functions, because you have to remember the context in that case. So is this nested function allowed to be within this parent function, and things like that, and can go inside so many levels. Oh, blackout. Was it me? Okay. In general, also here, try to balance completeness and speed. You may think, okay, the goal of validation is to report you all the errors, right? And that's true. Sometimes, though, to collect the metadata you need, it might require time. You might go through an async call, and you need to balance that, because having an error reported after 5 seconds is not great on an editor. So we all complain when TypeScript jobs got stuck in our IDE, we have to restart it, right? Imagine having this for every single time you write a query. So having some caching system under the hood might be useful. And it's also okay to have partial validation. So having a system which is resilient to this kind of problems and just report, I don't know, the first 2-3 things, or maybe skipping a different check. Some use cases for this where, for example, an LLM use case. So we have an agent which was generating the statement in this language for the final user. Now, the problem is the only people knowledgeable about this language were me, my colleagues, and maybe the LLM, but just for 5 minutes. So it doesn't know much about that. Having a resilient validation thing make it easier, because you can focus on the type of error you want to train the LLM on for your language invented 5 minutes ago, and you can feed the output to the LLM, which will learn iteratively that, and or just, you know, having a shallow validation and propose when this shallow check passes to the user the final result of the agent. Another thing is, it's frustrating to see a lot of red on the editor. So don't try to show everything to the final user. Collect all these diagnostics, but try to cherry pick what to show, because having a statement entirely red is not great, and user will quit as soon as possible when he sees that. So try to build an experience which is great from that side. Easy to say, a little bit more challenging to actually do it. Okay, so now we built our validation engine, and let's talk about autocomplete. If with the validation engine we had to only collect the information when a statement was failing the parsing, well, with autocomplete, we are on completely the other side of the spectrum. 99% of the time you receive an invalid statement, and you have to work out what to propose to make it valid. So how can we do that? Well, that's tricky. There are different approaches. The library I provided, we actually use with everything or nothing approach. So if the statement is invalid, what we get is just nothing as an abstract syntax tree. Some other libraries provide actually hooks at the parsing level. So it will go one step at a time and reporting when something goes right and when something goes wrong. So you can have a partial AST. Meanwhile, the pro and the cons of these things are that, I mean, you can build an hybrid approach, but it's not easy. I found a very simple pattern to actually resolve most of the issues. It depends on your language, of course, but it's, if you have a statement, by experience, you will learn how an invalid statement is made. And what you can do is actually fill in the gap with some fake markers to make the statement become valid, at least for on-the-fly parsing. So you parse it, you get your AST with these fake markers in it, and you remove them from the AST. So you have now a data structure you can reason about, but at the same time, you don't have all these fake things within the data itself. It doesn't work all the time. Sometimes it fails. So it depends on your language. As I said, other libraries offer hooks at the single parsing step level, and you can leverage that. Like with validation, use metadata here. So try to not overload the user when suggesting something. Try to scope it down based on types, based on compatibility of functions, all things like that. This is a very small skeleton for the suggestion code. So you can see that there is a maybe valid expression there. And actually, that's my guess. I mean, that's the handle expression output where I try to put these markers and make things pass, even though the initial expression statement is invalid. After this, after we got the AST, we got the cursor position. and we try to find the node within the JSD and express that and get that. Sometimes the fake marker is the actual node, and we have to handle that, but we will get a node context. So think about, you wrote a function like average of, and you are with the cursor as on the first argument. So node context will be the information about the parent function, and the node will be the first argument because we are there with the cursor. So now we can think about using, I mean, with TypeScript, this comes beautiful, but you can think about, are we within a function? Then let's get the function from the context and from our metadata and try to build some meaningful suggestion from that. One small tip here, on validation, you kind of have the overall view of the thing. You're just interested to know whether things make sense. So an overall approach, a function that goes through everything makes sense. With autocomplete, you have a lot of subjective decision to make. So sometimes argument X makes sense for function A and argument Y makes sense for function B, even though X and Y are both numbers and both functions accept numbers. So imagine like log, for example, some numbers don't make sense with log as an argument, right? With other functions, any number is fine. So you want to have a tailor-made suggestion function for each single definition. So probably it's a good idea to bake in any function definition. You can see here with a method like get suggestion, and then you can compute the suggestion fragment for that particular function. I know it's a little bit too much probably to condense in a 30 minutes talk, but now we made our language and we will bake it into Monaco editor. Monaco, has anybody used Monaco here before? Okay, great. So Monaco is a great piece of library that it's multi-language by default and enable you to have a full IDE within the web browser. It's quite easy to extend it because it requires a very minimal amount of information for configuration of a new language, fundamentally an ID and a tokenizer. A tokenizer is the inverse of the grammar library. So you give it a string and it gives you back a token. It can be written with a function or even like with regular expression. It doesn't need to be very specific. Additional parameters can be passed to this to Monaco, like our validation function, our autocomplete, a hover feature, and things like that. We will just scope down to 2. So it sounds like a great place to integrate our new language. Okay, I will just show very brief scaffolding also how to integrate in Monaco. You can see the first object, it's just a very shallow definition of my language. Some themes, if we want to use some custom colors. Token rule is the tokenizer. So we explained that when you meet a string with round brackets, that's a function. Let's color it in pink. And then we got a function called service or services, whatever, where you return all the services like validation, autocomplete, these kind of things. Now, this object, it's a completely arbitrary data structure, but roughly resemble the foundation, what is called language service provider, which is an entire big topic that is actually makes it easy to integrate this thing into any editor you want, not just Monaco. Then you got this object in your hands and you go to Monaco and you say, can you register this language by this ID? And also the language configuration is this. This is the tokens provider and, you know, theme, blah, 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 everything like that. It's really few lines of code. And that's it, to be honest. Monaco will just pipe to your services and make it work. So now I covered all the topics here, and you know how to draw a null or how to implement your JavaScript language into Monaco. So I'm available for any question for detail. I got it, but I think we are quite close to the ending line. So thanks everybody for listening me for this time.